Hello everybody. Today's webinar is a simple and economical way to obtain excellent TOC combustion analysis results. My name is Christina Mason, applications chemist with Teledyne Tekmar. I've been with Teledyne about a year and a half. I've been the TOC applications chemist. Webinar, we're going to discuss TOC using method 5310B and EPA method 415.1. The reason that we all do TOC is to analyze for oxygen, which is to access potential oxygen-demanding load of organic carbon, so fish and living organisms that are in the water. If there's a pollution, it takes up the oxygen demand, and obviously it's hard on the living creatures of the water world. So standard method 5310E and EPA method 415.1 came out to regulate how much TOC is acceptable to be discharged and how we need to transport. And so it dictates that inorganic carbon needs to be sparged out and about doing this. The first is standard method 5310, commonly used for wastewater, groundwater, source water, and that sort. We'll get an overview of what 5310 is necessary for TOC analysis. First, that the inorganic carbon must be removed, and then when organic carbon is removed, it takes the remaining carbon and oxidizes it to CO2, and is measured by an NDIR detector, so non-dispersive infrared. As for 5310B, it's necessary that there's a demonstration of precision. More into that later in the presentation, but it basically means that you are analyzing samples the same way from one to the next. Remember before you start, and so that the system is clean. That means clean glassware, the flask that you're preparing your standards in, the deionized water that you're using to make your standards. Glassware in the unit would be the mist trap, the IC sparger, that there's not any contaminants in it. Addition, you'll use either ultra-zero air or oxygen, 21% phosphoric acid, which is produced with 94 milliliters of deionized water and 80 milliliters of 85% phosphoric acid. As I mentioned before, the summary of 5310, there's precision and quality control that is needed for this method. Every 10th analysis, every 10 samples, blanks, cleans, anything of that. So it's necessary to analyze a new blank and a laboratory control sample. Basically, this is a check standard that's showing that your calibration is still within range and that you're analyzing all your samples correctly. Demonstration of precision is with equation, and it's the amount difference between two samples that's allowed. So you run 1 ppm. If you plug it into this equation, it'll tell you the difference that you're allowed to have between the two 1 ppm samples. Figure 10B is similar to EPA method 415.1. They require inner carbon to be removed, that you separate your unit, a lot of the same. So work that a little bit. 415.1 is used to analyze natural sugars, mercaptans, oils, cellular fibers, oil matters absorbed on cell particles. Here's a listing of different examples of all of these. A lot of these are wastewater plants, wastewater treatment plants, stuff of that nature, groundwater, source water. So it's similar to 5310 and what it's used for. A summary of it, it's to disparage out the inorganic carbon. Samples need to be preserved if they are not used within 2 hours. So if you have a sample and you're going to analyze it, you preserve it. But if it's going to be the next morning before you get to it, 15.1 acid is preserved with acid. In addition to preserving it with acid, it's encouraged that you store it in a cool area that's protected from sunlight and atmospheric oxygen. Calibration with potassium hydrogen called KHP. This is 310 also. It's calibrated with the same solution to be analyzed. And it's the same water used to prepare standards. Lotix TOC Combustion Analyzer has a tool that you can analyze the blank. It'll automatically calculate that out of your samples for you. You can avoid the math that you have to use or thinking about it. Just run a blank. It'll memorize the blank and then subtract that from your samples, as 415.1 says it needs to be done. So about 5310E and 415.1 of what to do. The sparging, the inorganic, calibration, blanks, cleans, rinses, stuff of nature. And so up to the customers and ask what's really necessary, what we need for the wastewater, plant water, TOC analyzing groups of people. And we found that it's important to have an instrument that's economical, that's easy to use the software, set up a calibration, easy to set up standards. Short run times leads to more things being done. So that's increased throughput. It's easy to change your catalyst. Your catalyst will last longer. You can change how your samples are run. So if a sample needs analyzed right away, you can do priority sampling. You can eat things from your schedule, make schedule templates, just super easy software. And finally, export and import with the LIM system. Done with a click of a button, you can export anything, import what you need. Everything's just simple and economical. Here, new Lotix Combustion TOC Analyzer. As you can see, the glassware is on top. It's easy, accessible. You can see what's going on, if it's clean, if it's dirty, if it needs change. The acid bottle was on top. Fill. Scrubbers on top. And it's easy to see if it needs to be replaced. It's 30 positions of the sample conveyor, combustion tube to right instrument, easy to pull out to change, get to the access. Finally, a water reservoir that only needs changed when it's empty. It does no longer need changed every day. It's pressurized, and it's just as out of the way. You don't really need to think about it. So, workhorse, glass stays, you can see it. You can see your acid, and your combustion tube is easily accessible. Lotix is very economical. We want to upgrade the parts, making less replacement parts, less downtime. Doing this, we remove the syringe and the pumper. We use a 7-port valve. We use a flow controller to save money. There's the expensive replacement needles. There's carousel mechanisms that are going to break. The life of the catalyst is lasting longer, meaning you have to replace it fast. You don't have much downtime. Finally, the calibration remains stable over time. We can go back to the picture, and as you can see there are no pumpers, no syringe, no 7-port valve, sample conveyor that's not going to have the issues that a carousel might have. So calibrations are important for 5310, 415. Instrument was calibrated with KHP. By doing so, I made a 1,000 ppm of organic carbon standard, 2.1254 grams of KHP into 1 liter of water, and then diluted down from there to make it working standard. Commonly, that most laboratories are calibrating from 1 to 100. What this calibration is showing is 0.5 to 100 ppm. Easy. You can make points if you need to. You can add them back in. You can save it. For R squared, it's 0.99. The Ds are beautiful here, all well below 5%. And the level points even look good. The 0.5 and the 1 are below 2% RSD. And that's what's important, is that we can have a calibration range that looks good on the low end and is looking good on the upper end with low percent RSD. The flow-through detector, so it's no longer pressurized, and heated to 750. It's flow-through. It's 80. It means that your catalyst is going to last longer and great on your low end and your high end. So to our accuracy and precision with the flow-through detector. You can see that it's passing, it's looking at the 1 ppm, and it's looking good at the 100 ppm. So it's a broad range with the flow detector. On the sample injection that we did here, we tested to verify consecutive measurements are obtained or reproducible within 10%. And and that the check standards pass. It's accurate, it is precise. 5 ppm samples and your 5 ppm check standards are close. Same for 25 to 100 and your ones. And you can see we ran a blank on this schedule, just as 5310 and 415 require. With this flow-through detector, see just how far we could push it. So we went from 0 to 20,000 ppm without dilution. This eliminates your need for several calibrations. You don't need a bucket. You don't need to have methods. You can just run everything at the same calibration, same method, and it really will increase laboratory production. Get what's done quicker. Not the different methods, calibrations, and it'll help out time. Single 0.5 milliliter injection loop. It takes about 13 to 15 minutes per triplicate. So this will make several methods. And we can see calibration from 0 to 20,000 is 0.99 linear. RSDs, 10 is less than 1%, and a 20,000 is less than 5% RSD. Calibration from 0 to 1,000. So here's the 0 to 1,000 curve with their RSDs. And here's 0 to 20,000 with the RSD. So I know several laboratories that need to run higher samples and lower samples, and this can be done with one calibration. RSDs in the point, so it's precise and it's accurate. We'll save a lot of time without having to think about injection volumes that you need for different methods. Acid is just one injection volume, one set amount of acid to disperse all your inorganic. It makes it so much more simpler with this flow-through detector. So 310B requires precision. Then is 0.027x plus 0.29. This is for a single operator, and this is change between two samples that are allowed. So we did it on a calibration that's from 5 to 10, and we have a difference of 0.302 for a 0.5 ppm sample. So compared for 0.5 to 10 was 0.999. So linear, and we ran samples in a row, and as you can see, they're less than 0.02 together, so that means they're precise. And as well, even though it's not required, we ran MDL. MDL was 0.054 ppm, so that's 54 pp. And this is the same injection volume as you would for 20,000 ppm, all the way down to 0.5. So and the MDLs were 54 ppb, and precision is demonstrated here. So as well as having a flow detector that is linear with a huge range, it's also important to have easy-to-use software. You have software that's similar to an app you would have on your phone, or that we're so used to having in technology. It's just easy. You can click around without being confused where you're navigating to. So the software looks like an application, easy to navigate. There's a section for calibration, and because there's a flow through, it is at 6E. We won't calibrate as often, and won't be calibrating as often. This is for your schedule. This is your rinses, your blanks, check standards, and examples. There's an area for reports. You can get them as a CSV or a PDF. You can export them. The configuration screen and diagnostics for troubleshooting. So configuration screen. Area to name each instrument. So if you have multiple Lotix and you keep your data straight, you can instrument into standby or you cannot. So if 30 minutes, we'll go into standby and this will shut off your gas so you can see gas flow. And also if you want to lower the temperature in which the furnace stays, and you can do that as well. You can auto export the reports for every sample, or you can do it after the whole report is complete. Two ways of doing this is CSV or PDF. Use your folder to auto export as. In addition to auto export, you can auto print. And you do it the same as the export. You can either auto print after every sample or auto print after the whole report is complete. And dive into a folder to keep the data for years. Do to export, save your data, and print. Also on this configuration screen is the corrective actions. So if you are a laboratory that needs your RSDs to meet within 3 or 4% or your deviation, you can select these boxes and run an extra replicate to get RSDs for a sample to be below 5%. Calibration standards not only need to pass, but they need to pass within 5%. Then they run a new one and kick out the one that made RSDs too high. You can select if you want this for check standards, calibration standards, blanks, or samples. You need it for one or all four. Check standards, not only can you add an extra rep to get your RSDs or standard deviation. If standard fails, you can have the system rinse the whole Lotix and then run the check standard. Or you can just have it abort immediately. So you don't want to waste your samples that you only get one chance of running if your check standard doesn't pass. Or just continue. Really helpful corrective actions to have. You don't have to rerun your check standard. It'll just do it for you or have your RSDs meet. Here's also where the system input and export can be done. So if the information needs to be imported to another computer or exported, you can do it quickly with just a couple clicks. Also here you can change method parameters if you need to increase your acid volume or if change your furnace temperature, anything of that sort can be changed in your method parameters. Lotix TOC software will come with TOC method, a TC method, an IC method, TC minus IC method, and then finally a method to help condition catalysts that just makes it quicker. For calibration, as we can see, is calibrate. You calibration, and then when the whole calibration is complete, there's a calibration editor. Calibration editor, you can remove points. So if you run 7 points, but you only need 5, you can remove 2 to get the R-squared value that you need. Your blank here as well. So if you just want to run a DI water and make that your blank, it's possible to do that here. And then the samples you use can either use the method or the y-intercept, and you can toggle between the two. Gives you a visual representation of your calibration curve. Point curve generally takes less than 2 hours. And as mentioned earlier, triplicates between 13 to 15 minutes. That does depend on your concentration. For a curve that went up to 20,000 ppm, those samples did take a little bit longer because you have to wait for your curve to come down. This is what the sample schedule will look like. This is also what the calibration schedule will look like, only it's calibration. It's really easy software. There's not too much there. And answers, your blanks, your check stands, and your samples here. You can add priority samples just by doing a right click or delete something if you need to do that as well. And so under options, you can add samples, delete, insert below, insert above. Everything you're just used to doing with your right click of a mouse as well. This where the outlier deletion can be used. So you need your samples to be within 5%. It'll add in an extra sample and delete the outlier. Real-time viewing of the samples. As you can see on the green peaks in the right corner, it shows you your samples as they're coming out, and that can be enlarged. That picture can be put off as well. As for finishing, you can print them off on the fly. So if you need a sample report printed off, you can do that. You don't have to wait for the whole schedule to complete. Also, here it shows the sample conveyor. If you select a sample, it will select that position on the conveyor. If you select conveyor, it'll select it on the schedule. So easy to access. You know where you're putting your vial. The blue number 3, as in this picture, shows the sample that is running. So if you're across on the other side of the lab, you can see what position that you're on. And gray means that it is complete. So you can see visually across how many samples you have left or how many are complete. It's really easy software. It's easy to maintain. The combustion tube is easy to take out. There's 2 screws that need removed, and it just slides right out. So there's a injection block on the top, a 0.5 milliliter injection volume sample loop. As well as for the easy maintenance, there is a water reservoir that can hold water for weeks. Keep contamination out, and you don't have to fill this daily. You just have to fill it when it's empty. Flow-through detector will show peaks instead of blocks as the sample coming out. And the catalyst, there's a longer life. The furnace is programmable. You can put up to 1,000 degrees. Now it's at 680, and it helps preserve the life of the catalyst. So in conclusion, Lotix is the ultimate solution for wastewater, water, groundwater, seawater, and other hard-to-oxidize major seeds with an economical price to fit any budget, and easily surpasses requirements for methods 5310B and 415.1. The Lotix is a workhorse that we designed to meet the needs of day in and day out of every laboratory. It's economical, it's easy to software, and it gets the job done every day. So any questions, please let us know. You can contact us at tech support. You can call and ask questions. And also, there is an application note that is available on our website at teledynetekmar.com. that gives lots of information about 5310 and 415.1. Thank you all for listening.